Hello and welcome. Today, we're diving into one of the most important but often misunderstood concepts in software development, the executable file, or what we usually call the .exe file. But instead of jumping straight into technical jargon, I want you to imagine something much more familiar: a kitchen, some ingredients, and a beautifully packaged meal. Think of writing code like preparing food. You're selecting your ingredients, chopping, measuring, and organizing everything before you start cooking. That's the equivalent of writing your source code. It's the raw material, the onions, potatoes, and spices for a curry. But can we eat those ingredients just like that? Of course not. Just like in cooking, raw ingredients need to be transformed. They need to be handled properly, combined, and heated just right before they turn into something edible. That's where the cooking process comes in. And in software, that process is called compiling. Now here's the twist. Imagine you've cooked a delicious curry, but you're not serving it immediately. Instead, you carefully place it in a container, seal it tight, slap on a label, and put it in the fridge. Now, it's a ready-to-eat meal. Anyone can take it, heat it, and eat it without knowing the recipe or the steps it took to make it. That final packaged meal, that's the .exe file. So, in simple terms, source code is like ingredients. The compilation process is the cooking and packaging, and the executable file is the finished sealed meal, ready for anyone to consume anytime, anywhere. Let's unpack that a little further. When a developer writes code, they're not creating something that can immediately be used. They're creating the instructions, the blueprint. But those instructions aren't useful on their own unless they're transformed into a form the computer can understand directly and act upon. So think of this. Source code is like raw vegetables, uncooked meat, flour, each with a purpose, but inedible until they're processed. Now enters the compiler. The compiler is like a master chef robot in your kitchen. It follows your recipe, handles your ingredients, and automatically turns them into a perfectly cooked dish. But it does something more. It seals the dish into a microwavable container, labels it, and makes it ready for distribution. That's the .exe file. Once you have that .exe, even someone who's never stepped foot in a kitchen can enjoy the result. They don't need to know the recipe. They don't even need to know what's inside. They just open it, double-click it, and everything works. That's the beauty of the executable file. It encapsulates all the steps, all the knowledge, and all the preparation, so the end user doesn't have to think about any of that. This is why software companies don't send you the source code. They send you .exe files. You don't need the recipe, you just need the meal. Now let's say you're sending that packaged curry to a friend across town. If you hand them the ingredients and tell them to cook it themselves, you're assuming they have the tools, the skills, and the time. But if you hand them the sealed, ready-made dish, all they need is a microwave. That's exactly how compiled software works. The developer prepares everything and gives you a version that just works. But let's go deeper. What about the environment? You see, when you package a dish, you also need to make sure it's compatible with the person's kitchen. If you send a dish that needs a microwave but your friend only has a gas stove, you've got a problem. Same with .exe files. They're usually made to run on Windows. If you try to open a Windows.exe file on a Mac or Linux machine, it might not work. Just like giving someone a frozen dinner that their kitchen can't reheat. That's why developers sometimes create different packages for different systems. Windows might use .exe, Mac OS might use .app, and Linux might use other formats. The meal stays the same, but the packaging is customized for the person's kitchen. Let's circle back. We now understand that writing code is like preparing raw ingredients. Compiling is like cooking and sealing the dish. And the .exe file is the final product, the neatly packaged meal. Now here's something beginners often overlook: portability. One of the biggest advantages of compiling code into an .exe is that it becomes portable. You can send it to someone else, and they can use it without knowing anything about how it was made. They don't need to install extra tools. They don't need to understand the code. They just open it and go. This is why companies compile software before distribution. It simplifies everything for the user. Think of it like this. Would you rather give someone a grocery list and a recipe, or just hand them a finished meal? In real life, the answer depends on context. But in software, when your goal is to reach users who don't write code, the .exe is the only answer. There's also the matter of security. If you hand someone your source code, you're revealing the secret recipe. You're showing them every step, every technique, every detail. But if you give them just the .exe, they only get the result, not the how. That's often desirable. Imagine Coca-Cola handing you not just the drink, but the entire formula. That would be risky, right? In the same way, companies protect their intellectual property by distributing the final product, not the recipe. Here's another thing: version control. Let's say you've improved your curry recipe. You add better spices, reduce the salt, maybe switch from chicken to tofu. But you don't want to explain those changes every time. You just want to give people the latest version of the packaged meal. Same with .exe files. Every time you update the source code, you compile it again and generate a new .exe. Users throw away the old one, download the new one, and everything just works. No need for them to read your changelog or understand your design decisions. They just enjoy the upgraded flavor. Now let's talk about how this relates to real-world distribution. When a developer releases software, they're often thinking far beyond their local environment. Maybe their code runs on their laptop just fine. But what about their client's machine? What about a corporate network with tight security? What about users in a different country? That's why compiling matters so much. A properly compiled and packaged .exe is like a travel-safe meal. It can be emailed, uploaded, downloaded, and stored on a USB stick. It can be installed in a school, a factory, or a home office. Just imagine you're delivering hundreds of packed lunches to a conference. You wouldn't bring raw ingredients and hope every attendee has a kitchen. You'd bring sealed boxes, ready to go, neatly labeled, nothing to explain. That's software distribution in a nutshell. Before we wrap up, let's revisit what we've learned. Source code is your raw ingredient list. It holds all the logic, flavor, and structure, but it's not ready to consume. Compilation is your cooking and packaging process. It transforms the ingredients into a cohesive, safe, and accessible dish. The executable file is the final, user-friendly product. It's a lunchbox anyone can open, use, and enjoy without asking how it was made. And that's what makes software so scalable. Once you've compiled your application, you can send it to 10 people, 100, 1,000, no extra work. That one .exe file can serve them all. That's the power of compilation. It's not just about making things run. It's about making them run anywhere, easily and safely. So the next time you see an .exe file, I hope you'll think of it not just as a technical artifact, but as the end of a long and careful cooking journey. You started with ingredients. You followed a recipe. You cooked with care. And finally, you sealed it into something that's ready to be shared.